Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Okay, let us continue our lecture in subtopic 3.1 roots of nonlinear equation with new method, Newton-Raphson method. Okay, you must remember our aim is to find the solution of x, or we want to find the root of solution fx. For Newton-Raphson method, only one initial guess is needed to get the iterative process started to find the root of an equation. Okay, before this, we have learned about bisection method. Okay, bisection method need two initial guess to start the iterative process. Okay, so this is the formula we call Newton's iteration, which is xi plus 1 equal to xi minus fx over f prime xi. Okay, for Newton-Raphson method, the convergence in this method is not guaranteed, but if the method does converge, it is much faster than the bisection method or bracketing method. Let's see example 1. Use the Newton-Raphson method to estimate the root of fx equal to x squared plus 2x minus x equal to 0, accurate to epsilon or error 0 less than 0.001, and given an initial point is x not equal to 1. Okay, use 4 decimal places in all calculation. So you have initial point here x not equal to 1. Okay, you have to calculate the error less than 0.001. Okay, first we have a formula for Newton-Raphson method here. So use formula of Newton-Raphson method. So differentiate fx, you will get f prime x equal to 2x plus 2. Okay, now substitute the initial value 1 in the f prime x. You will get 2 times 1 plus 2 equal to 4. Okay, the reason why we have to substitute the initial value because we want to make sure the initial value is suitable to use in Newton-Raphson method. So f prime x naught is the denominator. So you can see here, if the denominator is equal to 0, you will get error. So you have to make sure f prime x is not equal to 0 or approximate 0. So for this problem, 1 is suitable for the initial value and to proceed the Newton-Raphson method. Okay, next step, we have to draw the table. So first column is I, which is the iteration. Next is xi. Okay, next is fxi. Next is f prime xi. And last column is the error, which is xi minus 1. So let's start with iteration 0. So the initial point is 1. So you substitute 1 in fx, you will get negative 2. Substitute 1 in f prime x, you will get 4. And no error for the first iteration. So next, for the next iteration, which is 1. Okay, now to find the x naught, you will use the formula for Newton-Raphson method, which is x1 equal to x0 minus f x naught over f prime x naught. So here you substitute x naught equal to 1, f x naught equal to negative 2, and f prime x naught equal to 4, you will get 1.5. Okay, next substitute 1.5 in fxi, you will get 0.25, and for f prime x1 you will get 5. So the error here is 0.5, which you 1.5 minus 1. Okay, next iteration. Okay, before that, for the error, we still not get the error less than 0.001, so you have to proceed to next iteration. So for iteration number 2, okay, since that to find x2 you use the formula for Newton-Raphson method, so you will get x2 equal to 1.45. Then you substitute in fxi and f prime xi. So for the error, you get 0.05, okay, still not less than 0.001. So proceed to next iteration. Okay, iteration 3, you get x3 equal to 1.4495. Let's find fxi and f prime xi. So you find the error. So 1.4495 minus 1.45, you will get 0.0005. So this point is less than the error given 0.001. So you have to stop the iteration here. So our point or the solution for this question, for this problem is 1.4495. So you can write here the root of fx equal to x squared plus 2x minus 5 is approximately equal to 1.4495. Okay, let's move to next example. Solve x cubed minus 3x minus 1 equal to 0 using Newton-Raphson method with initial value x not equal to 0. Okay, use 6 decimal places in all calculation. Okay, so the question give you the initial value x not equal to 0 and the fx is equal to x cubed minus 3x minus 1 equal to 0. Okay, so for this question, it is the question not given the absolute value or error value. Okay, so you don't have the stopping criteria. Okay, now you find f prime x. So f prime x equal to 3x squared minus 3. Okay, substitute 0 in f prime x, you will get 3 times 0 squared minus 3 equal to negative 3. So 0 is the suitable initial value for this problem, so you can proceed to to find the value of x using Newton-Raphson method. So next, you construct a table. So for the first column is I, second is xi, third is fxi, and f prime si. So let's start with iteration 0. So xi here is x not here is equal to 0, so 0. You substitute fx, you will get substitute 0 in fx, you will get negative 1. Then substitute f prime, substitute x naught into the f prime x naught, you will get negative 3. Okay, next find the iteration number 1. So the x1 here you can find by using the Newton-Raphson method. So you will get negative 0.333333. So here you have stated you need to find 6 decimal places. Okay, for fx you will get negative 0.03737, and for f prime x1 you will get negative 2.666667. Okay, next for iteration 2, same step, you repeat the same step. So for xi you will get negative 0.347222. For x2 you will get negative 0.000196, and for f prime x2 you will get negative 2.638310. So next, for iteration number 3, you will get x3 equal to negative 0.347296, and for the fx you get 0.000000. So now you can stop the iteration because you have reached the solution. So the x here is approximately equal to negative 0.347296. So I think that's all for this video. Thank you.